As we begin Chapter 5, we're looking at why measurement is such a critical part of program planning, evaluation, and research. This chapter also introduces major types of validity and reliability, concepts that help us judge whether our tools and data are trustworthy. We'll also explore how to create or select measurement instruments, the difference between probability and non-probability sampling, and the role of pilot testing. These skills form the backbone of rigorous research and evaluation. Measurement is essentially the process of assigning numbers or narrative descriptions to people, events, or objects. Sometimes that data is numerical, sometimes it is descriptive, and often we strengthen our conclusions by using multiple data sources, a process known as triangulation. Understanding measurement is essential because it shows up everywhere. Reviewing literature, conducting needs assessments, and evaluating programs, reporting results, and even convincing funders that your program is worth supporting. Strong measurement skills make your work more credible. Different levels of measurement generate different types of data. Nominal data simply categorize things, while ordinal data allows us to rank categories. These distinctions matter because they determine what kinds of analyses we can perform. Interval and ratio data take us further by allowing continuous measurement. Ratio data include a true zero point, which opens the door to more advanced statistical techniques. Choosing the right level of measurement early on affects everything that follows. Because different types of data require different statistical tests, it's important to match your measurement approach with your planned analyses. Nominal and ordinal data use non-parametric tests, while interval and ratio data allow parametric tests. Visual data displays like tables and charts help communicate your results very clearly. Every data collection effort requires measurement instrument. In health promotion, these tools can range from equipment to questionnaires. Regardless of the form, each item on an instrument must be carefully designed to capture the information you need. Health promotion programs often measure demographics, awareness, knowledge, psychological factors, skills, behaviors, health status, and quality of life. These domains help us understand both who we're serving and how our programs are influencing them. Good data have strong psychometric qualities, meaning they're valid, reliable, and free from bias. Reliability ensures consistency, while validity ensures accuracy, and bias-free data reflect the true value of what you're measuring. Reliability comes in several forms. Internal consistency looks at how well items on a scale relate to each other. Stability examines consistency over time, and rater reliability ensures that observers or raters are consistent, whether it's one person or multiple people. Validity also has multiple dimensions. Face validity is about appearance. Content validity ensures the coverage of a topic. And criterion validity examines whether your measure aligns with other indicators, either now or in the future. Construct validity digs deeper, asking whether your instrument truly measures the underlying concept. Convergent validity checks whether similar measures correlate, while being discriminant validity ensures that your measure doesn't correlate with unrelated constructs. Reliable and valid data are the goal. When your measurement tools consistently hit the target and measure what they're supposed to measure, your findings become far more trustworthy and actionable. Sensitivity and specificity are especially important in screening and diagnostic contexts. Sensitivity identifies true positives, while specificity identifies true negatives. Both help determine how accurate a test really is. When selecting an instrument, start by searching the literature and available tools. Once you find one, evaluate whether it fits your population, context, and goals. If it is not in the public domain, you'll need permission to use it. If no suitable instruments exist, you may need to create one. Clear wording, appropriate response options, and a professional presentation are essential. Your instrument should be easy to understand, easy to complete, and easy to analyze. Sampling determines who your data will represent. A census includes everyone, while sampling includes only some members of the population. The sampling unit is the element that you are selecting, whether it be individuals, schools, or communities. It is important to distinguish between the universe, the population, the survey, the population, and the sample. These distinctions help clarify who you're studying and who your results will apply to. This visual helps illustrate how these groups relate to one another. Understanding these relationships helps you design studies that are both feasible and representative. Sampling must be done carefully to avoid bias. Sampling bias occurs when your sample doesn't accurately reflect the population. There are two major categories of sampling: probability and non-probability. Probability sampling uses random selection and requires a sampling frame. This approach gives every unit an equal chance of being selected, which strengthens generalizability. Probability sampling includes methods like simple random sampling, systematic sampling, and stratified sampling. Each method has strengths depending on your population and research goals. Non-probability sampling is used when random sampling isn't feasible. These methods are practical, but come with limitations because not everyone has an equal chance of being selected. Non-probability methods include convenience, homogeneous, snowball, quota, and maximum variation sampling. These approaches can be useful, but they require transparency about their limitations. Sample size depends on your resources, the precision you need, the differences you hope to detect, and the statistical procedures you plan to use. Planning ahead helps ensure that your sample is adequate. Pilot testing is like a dress rehearsal. It helps you identify issues with your instrument or procedures before the full implementation occurs. Early reviews and cognitive pre-testing can reveal problems you might otherwise have missed. Mini pilots and full pilot tests allow you to test your instrument with members of your target population. This helps you assess the reliability and validity before collecting real data. Measurement always involves ethical considerations. Participants must volunteer freely, their data must be protected, and analyses must be appropriate. Legal requirements such as HIPAA also apply when dealing with sensitive health information. The chapter wraps up by reinforcing key concepts like levels of measurement, psychometric qualities, and the importance of reliability and validity. It also reviews the steps for selecting or creating instruments and the reasons sampling is necessary in research. Finally, the chapter highlights the major sampling terms, sampling methods, and ethical issues that must meet all measurement efforts.